Good afternoon and welcome everybody. My name is John Holt. I'm the current Technical Director of Incosi UK. We're joined today by Kim Stansfield and John Fraser, whose paper, Stakeholder-Needs Driven Systems Development, a Flexible Automation Case Study, is in the proceedings for our last ASEC and was held as a reserve paper. So we're giving them the opportunity to present this now. This will be recorded and it will be made available on the Incosi UK website. So Kim, anybody that's been involved with Incosi over the last couple of decades, I was going to say then. Okay, anybody that's been involved with Incosi UK, let's put it that way. He's probably aware of Kim. He's a prolific author. He's got a very varied background. He's currently an independent consultant for Vocate, and he's also just started teaching some courses on, I believe it's systems thinking at Warwick University. We're also joined by John Fraser. He's co-author of many years from who currently works at AWE. So without further ado, I'll hand over to our two presenters. So over to you, Kim.
Great. Thank you, John, and welcome everybody. I'm going to do a very, very quick run through of the paper. The scope is probably too big for standard ASEC papers, but hopefully I'll just get over the key points. I'll then hand over to John, who will talk about a second core aspect of the paper, which is about the system engineering quality management attributes. We'll explain more as we go through the talk. So, okay, this is the summary paper that we were hoping to present at ASEC last November. Co-authored by myself, John Fraser, Steve Dimolo, who possibly might be on the call, possibly Catherine Chan and Glenn Mazer. And we can see their associated job titles. Can see John's still down as Protein Electric, which is a bit of a missing piece that I haven't spotted previously. I'm from Vocate. It's my own little company, voice of the customer across the ecosystem. And maybe we'll pick up a bit more on that as we go through. So I'm just going to go through brief introduction to QFD and benefits, both traditional and modern QFD. And then I'm going to look at the case study B3414, which is a project I was involved in back in 1990, which is where I understood more about the classic QFD approach. And then I'm going to do a comparison with how that's been modernized. And we're then going to hand over to John, who will do a few slides on the system engineering quality management attributes, and I'll take it up again to talk about the conclusions. So the paper that was presented, or was due to be presented, if accepted at ASEC, looked at a larger paper I did for the International Symposium on QFD, looking at applications of QFD, both the classic form that was applied in 1990 to design of an automated composites fabrication system with inline quality assurance. That's where I learned to apply QFD approaches, and it followed sort of various degrees in materials science and technology, PhD funded by R.E. Farnborough on composites for supersonic fuselages. Anyway, subsequently, my career went through vehicle telematics integration, vehicle control systems for collision avoidance systems, quality assured design of large enterprise systems with Northrop Grumman Mission Systems and CSC, and then the Energy Technologies Institute, applying the same methods to try and improve the way we design energy systems for domestic and industrial. I then moved into academia in 2016, where I became Associate Professor of Transformational Systems Engineering. But the bit I'm really going to ask John to talk about at the end is how we perceive the project that I learnt QFD on and the subsequent development of QFD and SEQM, Systems Engineering Quality Management Attributes. So why quality assured design? Japan, 1968, a lot of progress on TQM as applied to manufacturing. but it was appreciated by Yoji Akao and Professor Shigeru Mitsuno that the designs that were coming through were crap. That's the technical terminology. And they realized they had to find a way of embedding positive quality. What is the quality that's required from the design of the product or the manufacturing system? And actually, when I learned about this approach, it was part of a concurrent engineering framework. Why do we do it during design? Because during design, changes are cheap by comparison with changes during development and during manufacturing or during service of a product. So we're talking today about the design of positive quality to get above the line from 0 defects at the right of the diagram we see here. This is what Akao and Mitsuno were doing. So just to reinforce that statement about cost of changes cheap, this is what Ford spotted when they took controlling stake in Mazda. Sequential engineering practices that they were deploying, very expensive, and they noticed design changes were closed down earlier at Mazda because they were applying QFD. And the cost implication of that is Ford are doing all the changes in the expensive blue bit at the right, where we're now going exponential in terms of cost and negative impact on company. Mazda have finished that because they're doing a lot more change early on in the design process. And this really becomes the key advantage that companies like Toyota have realized as well. So, but Akao was not just happy with developing the QFD method along with Shigeru Mitsuno. He also introduced in 1968 Hoshinkanri policy management, aligning aligning policies within departments, within your personal workplace, with the company vision and strategic goals, a small number of strategic goals, using the metaphor of navigating a boat across prevailing winds or changing tides. So how do we do that? And his view was we link everything systematically together to ensure we're all steering in the same navigation route. So in 1990, when I was joined Lucas Engineering and Systems, we were working on behalf of Lucas Aerospace, and B3414 is the case study project. At that time, they'd spent a lot of time studying the Japanese and come to the conclusion the best format design framework involved a 4-phase QFD's spine, supporting the concept design, design improvement, and further design, manufacturing design improvement. So this is basically a concurrent engineering framework, subsequently adopted by the Design for Six Sigma community. And I've got to say that the Design for Six Sigma community have stuck in the rut that has subsequently been expanded on by the QFD community. So today's talk will focus on internal stakeholders. We're looking at improving internal manufacturing processes through automation. I should stress stakeholders. My definition is any person, group, or organization that has a significant impact on the success or failure of a system development, deployment, operation, or disposal. So the whole QFD thing is to look across the whole life cycle to understand the impact. I can see a few typos on this slide. I'll clean those up before I release the PDF. The B3414 manufacturing automation case study really focuses on those internal stakeholders. So I'll talk about those a little bit more. And internal stakeholders tend to be the people who are either setting the goals for the business, the strategic people, the finance department, or the engineering department heads. And then we have the stakeholders in terms of deploying what is coming down as policy from the company into things like the design process, the manufacturing process, the quality management processes, etc., etc. So the B3414 case study was looking at manufacturing of pre-preg composite components. And really, these are thin layers of composite, typically carbon fiber or glass fiber reinforced semi-cured resin. Big challenge. Many of the design features, as we'll see in a second, are really flipping difficult to manufacture. I think that's the technical manufacturing term, because many of the designs have been designed for metal and then stuck into composite because it's lighter and stronger and stiffer than metal. Okay, I've got a video, simple video of the basic layout process. Don't really have time to go through that today. So for the companies involved in B3414, Lucas Aerospace, we're looking at things like engine nacelles for the V-22 tilt-rotor vertical takeoff aircraft, which incorporates de-icing equipment. As I told them back in 1990, you're basically working on a smart structure. And then Krupp, looking at slight double curvature, which is difficult to do in composites. So Lucas Aerospace, really complex, multi curvature components with various design features. A couple of example components. One's a close-out baffle, one's an access door. Why RoboComp? That's what we, as a team, called B3414. Basically, the automation out there at the time, tape laying equipment, is okay if you're doing really relatively flat panels. Not so good if you're doing complex architecture components, as we were. So basically, we're trying to automate mechanisms, embed quality assurance into it. It's flipping expensive to get to the end of the process and discover you've got to start again. And increasing the quality and repeatability of processes, but making it flexible so it can manufacture for a range of low volume, high value components. There was a fourth piece of the program, which was about development of a knowledge-based engineering solution to help designers pick the best manufacturing route for their design of component. But I'm not going to discuss that today. At the time, we basically did a simple program high-level goals and requirements statement, as seen here, the kind of things that you'd expect to see for a process improvement project. And getting back to Yoji Kao, what he was saying was we should be doing more to systematically link business vision, which typically gets tied up in terms of the kind of markets you're going to be working in and the way you're going to excel in your marketplace, what that translates to in terms of business goals, how that feeds down to department and program goals, and how that feeds down to personal goals. This is the Hoshin Kanri flow. So modernization of QFD that's been going on. I've been part of the ISO 16355 development group since 2010, where we're taking developments which are focused on improving the agility of QFD, improving the maths behind it, because a lot of the traditional classic QFD was based on Japanese use of an abacus. Not ideal if you're trying to work out relative impact to different needs on success for the program. So this has really been going since Richard Zoltner developed Blitz QFD back in 1995. So it's been around a long time. Glenn Mazer, one of my co-authors on this program, and Richard Zoltner moved that to cover the whole of the QFD framework. So that's where it moved to, with these enhanced methods, including replacement of traditional pairwise comparison with AHP. Anyway, this is the different parts of the standard that are out there. And it's now part 7, it's the last bit, QFD for digital products. That's about to be published by ISO. So it's been a long haul since 2010, but we've now got all 8 parts. So what's that mean in terms of the program goals, the high-level goals and high-level requirements table that we used in 1990? Basically, the suggestion is that we develop that into a business goals table, which sets out the business goals statement, what does the means of implementing that mean, and then associating each of the stakeholders that were concerned with have we achieved the business goal or not. These are the high-level stakeholders of the program. This then flows down into a program goals table, where again, we do the same, but now we're looking at a specific goal or a specific means, which become the program goals and for a range of programs. So we might be working on, cost reduction, process improvement, new product design methods, whatever it might be. And I've worked in business change groups, so business change being a key way of introducing new technology into a company. So the goal statements really become the critical measures of success, and how are we going to measure them? What's the time frame? Who's judging success, and what does that mean? How are we going to do it? Okay, the who judges success are the strategic internal stakeholders who judge whether your system has been a waste of time or a crowning glory for your career. So they are pretty important stakeholders to consider. I mentioned AHP briefly, prioritizing goals. Classic, there's pairwise comparison. All that gives you is a rough idea of rank order importance. It gives you no idea of how much more important something is compared with another. And the modern QFD has implemented analytic hierarchy process, which gives you ratio scale importance. This is absolutely critical for systems engineering, where you might be deploying a high-level business goal down into a series of suppliers or partner organizations. If you can't do ratio scale importance, it's all back to guesswork. The rank order way of prioritizing was useful back in the 80s and early 90s, before things like Excel appeared, but now we can do AHP style calculations very, very easily and create the percentage improvement. So originally we did a classic house for quality QFD matrix, program needs across down the left, pairwise priority and system design requirements. And we came up with a list of rank order design, system design requirements across the bottom. We also did a process scoping using basic input-output analysis, including, as we see at the bottom of the chart, out of scope processes. So we had to put a boundary around it to make sure we were clear. We had 5 partners in the program, so which is each partner working on? In ISO 16355, we suggest an enhancement to the input-output analysis, which is now looking at the full chain from suppliers, inputs, processes, outputs, and customers. If you don't have the 2 outer suppliers and customers piece, and this actually flows throughout the process, so there are different suppliers and customers down the value creation chain. If you don't have those, you're really guessing again whether the output is required or not. So anyway, modern KFD talks about planned Gemba plus rich process mapping, which includes customer process models, SIPOC, swim lane. I'm a personal fan of swim lane process mapping. And as it says there, we include customers and suppliers. It's described in ISO 16355, part 2, published in 2016. Modern QFD approach continues further because we now start looking at the individual areas underneath the business goals. What are the high-level program goals, and these break out and can then be prioritized down through the hierarchy. As we see in this chart, we've done almost allocation of the requirements, the program goals against different modules within the system: cutting module, dereeling module, handling module, consolidation module, which was critical to us because we were allocating work across the different partners in the BE program. What we've done in this chart is actually rotate it through 90 degrees. So we've got flow from business goal 1 at the left, through the program operational goals, through into project high-level needs and requirements at the right in the yellow boxes. But they're the same chart, but turned through 90 degrees. Anyway, as I say, what we're aiming to do is to allocate system design requirements across the different parts of the process flow so that different partners can pick the work up. This is true for R&D programs. It's true for production development of programs. From this, we were able to create a concept development and allocate the different parts of the program. If we look at the modern form of the QFD matrix that is all I knew about back in 1990, the House of Quality matrix, the modern form is now creating, as we see across the bottom of this chart, ratio scales for the different importance ratings for system design requirements that address the program goals. Okay, so quickly illustrate with the cutting module. And we're doing 25, got a few minutes. So this is just looking at the cutting module. So in this program, Lucas Engineering and Systems were responsible for the dereeling, and the cutting module, which I'm showing there, is the underneath the gantry, which is the handling system taking cutout layers of pre-preg onto a mold tool, and that part of the system was run by Krupp Forschung Institute in Essen. And yeah, so we're also responsible for the PLC programmable controller that allowed us to manage the whole flow through the system. I should say high-tech Greek vision systems company was doing the inline quality assessment on the pre-preg coming in. We were told that there would be no defects in the pre-preg, and the very first piece we were sent to experiment on by the material supplier contained a series of dead bugs stuck underneath the backing papers, which is a nightmare for composite manufacturing if you don't spot those bugs. So we're trying to pick up defects before it gets into the production process. Okay, so turning the concept, I don't know if this is going to work. I'm just going to show for a few seconds the production prototype that we produced. I'm not telling you a whole load of things that we were doing alongside this: failure modes, effects analysis, design of experiments to shape certain elements of this system. This is the vision system picking up defects on the pre-preg. So when it gets the cutting system, we're making sure they were nested around the defects so that they weren't actually incorporating defective material. This is the cutting module in operation. And then handling system coming over, quite jerky because it's a prototype from Krupp. But what we're doing here is making sure we've got quality assurance. So we're making sure the handling system is not introducing defects in the composite. This is glass epoxy, relatively low tack, and it's just being lowered onto the system, the mold tool, sorry. And then there's different consolidation tools depending on the contour of the mold tool, and then flowing through to reliable, repeatable consolidation. So many of the components that were coming through at Lucas Aerospace with manual layup would get to the end of the autoclave process that follows this one and end up with a multi-thousand-pound component having to be binned because the system had not picked up defects introduced during manufacturing. Okay, this is another tool. Anyway, I'm going to carry on. One of the reasons I did the paper was because early on it became evident that the four-phase model that we'd embedded in our framework, which, as I say, is embedded in the Design for Six Sigma framework, was inadequate. Yes, it was good to start to find some of the real quality issues between design of product and manufacturing of product. It was not adequate when we then consider the whole process flow through to operation and beyond. And this was really reinforced when I was then working on enterprise systems. So often the design had not considered key aspects of the operational environment that a system was being deployed into. So my recommendation is we should be looking at a full life cycle model, not just design a product and design a manufacturing, but incorporating ratio scale prioritization throughout that whole process so that we understand the different stakeholders down the whole life cycle, not just initial purchase of a system or product. Not so relevant for consumer products, other than it might be something to do with disposal or recycling of materials involved in production process. So classic QFD, focus on customer stakeholder needs, attempts to prioritize criteria, understanding of goals, processes. So great, does concurrent design, product and delivery, and it provides a process, systematic process. But the negatives, classic QFD, that's the stuff I learned about in 1990. It focuses on house of quality and mathematically unsound, produces rank order priority, clarity of critical goals and process scope tend to be missing. Four-phase model over simplistic for systems, not supported with a standard legacy thinking. Focuses on US automotive builder print companies that use the QFD four-phase model, and it's just too simple. And it was a huge simplification compared with Japanese QFD approach. But it was considered the Americans' automotive suppliers were not intelligent enough to understand the complexity that Akao and Mitsuno had produced. Modern QFD did deep focus on customer stakeholder needs. AHP prioritization is mathematically sound. Rich development and analysis of goals and processes and stakeholders, visual hierarchy and multi-level system perspective. And we got an ISO standard that develops agile best practices, promoting multi-stakeholder understanding. So this is the basic strapline, QFD aligned system development to business and customer value. That's what it's doing. It's getting quality in on purpose, not by accident, which is a traditional design approach. So design it in rather than try and fix it after it's broke. I'll hand over to John now.
So I'm just going to go through my vocational certainty. So this is something I'm going to talk about in a minute. So on this slide is some of my background. So I've started at Brunel University. I then led me to a degree at AWE. And then from there, I then went to Protein Electric for 2 years and then back to AWE. But within that time, I did a master's degree sponsored by AWE. So what happens then is I got involved in COSI tutorial days, and I used to go attend them all. And the one that really changed my career was the day I met Kim doing the tutorial day for modern QFD. I was quite interested in QFD, and I was really intrigued to find out more in QFD. From there, the teaching that Kim gave me, I thought, oh, I'm really...
I'll carry on. So it's cohort 3 is launching 1st of March 2023. So if you want to get on that course because you're impressed with what John's about to tell you, then please make sure you go through the INCOSE, find the INCOSE SEQM group and email Larry Kennedy. I think you should have all the information. It's a course run by the Quality Management Institute that Larry has set up. 8 attributes of a quality manager. So the core thinking here is that actually whatever job you're doing, if you're managing other people in achieving an outcome, then you need certain attributes in the way you behave, one of which is vocational certainty, zero defects attitude, process quality, administrative consistency, executive credibility, personal authenticity, ethical dependability, and mutual respect, accountability, and professionalism. So at the end of the day, this is part of the quality management value chain, and it's imposed through the human values that you bring to bear in your job. And I've got to say, looking at it from a standpoint of somebody who's been through my career and seen the number of times that programs fail because somebody senior or somebody who you're depending on does not understand these attributes, it's just such a common theme. So for me, it's core to systems engineering, producing or diligently keeping their promise to their customer, recognizing in an internal value chain, it's a series of suppliers and customers for information, for models, maybe from SysML, from a process map that maybe has to be worked out before you can do the process modeling and development of system models. So it's all interlinked. It's all part of the business system delivery of new products, services, and systems. Do you want to pick up on this, John? Motivations?
Yeah, I will do until my broadband cuts out again. So one of the main ones of the attributes is zero defects attitude. So the motivations for zero defects attitude is pride in workmanship. Then there's number 2 is not expecting perfection, but the target is perfection. And then the third one is always keeping a promise, as Kim says. I always kind of look at the underlying section, business and customer needs and priorities. That just saying to me is QFD.
Yeah.
Next slide. So I talked about my vocational certainty. So I have a vision of what my career wants to do. I'm committed to personal excellence. So I'm targeting where I want to improve. I'm trying to develop the skills. So I'm always looking at who's the best expert in that field, and I'm trying to learn from them. So like Glenn Mazur for QFD, I'm looking around. Jeff Sulland for Scrum. So I'm trying to learn the expert in the field and learn from them the process and the tools and how to do these tools properly. So I'm always pushing myself to continuously improve, and I'm also trying to measure my performance. And then once I've achieved that, what am I going to do next?
Yeah, I should just quickly add that I think one of the challenges we see, number 4 there, press towards continuous improvement. I think this is where we get stuck with legacy ideas. I see it particularly in the QFD field, where people are stuck on a 4-phase classic QFD model. And it's like, automotive didn't develop beyond the Model T Ford. Yeah. Model T Ford was a huge step forward. But
I see that myself with even the tools today. We've got a P matrix out, and the P matrix is using the ordinal scale maths that you talked about earlier. And if you're not using ratio scale maths, it's giving you the wrong result. The maths is telling you the wrong thing. So you've got to continuously update your methods and tools to keep up to date and relevant in today's fast-moving world. So next one is this kind of shows me TQM, quality planning, quality improvement, quality assurance, and quality control.
Yeah, and all I'll say there, this is all built within building a quality culture. which is really where the attributes, the quality culture is about this focus on understanding how we individually supporting constructive development of new products, new services, or improving current ones. It's not just about the new product introduction. It's about how do we continuously improve our organization, the way we work with people. So this is where I think the SEQM attributes sit in supporting that. QFD then helps big time with quality assurance, improving the way we do quality control, and as we've seen earlier, really does help big time with quality planning. So, without these things, we're guessing. The challenge for many quality control people is that it's too late to say, we found the defect. How did the defect get in there? How do we improve what we've done to avoid having to correct the defects? Defects are expensive. When they get to customers, as they do with a lot of product design, it's a nightmare. It really does destroy customer value. So I'm just going to finish off very quickly. So if we look at the quality management value chain, product, services, and systems, we're trying to take business policy, voice of customer needs, and feed it through a series of customer-supplier relationships within our business and with our suppliers and with our partners. Each link in the quality chain, each internal stakeholder customer link really impacts the overall quality of the outputs, high quality value products, services and systems, or indeed the high quality value maintenance and support systems. And this is flowing through all the different business functions. Quality function deployment is about deploying quality into the business functions so that everybody understands what they're doing rather than the usual, we're doing stuff that might or might not impact quality. So failure in any one QA link compromises the quality of the outputs, and the process and culture is key, modern QFD and SEQM. This is me just flowing it into the classic V model with the multi-layers of the different V models that you need, from the quality of the architecture coming down the left-hand side, and then the mission definition and feasibility. I think too many system programs start off without doing any QA on the mission definition and feasibility. A number of times as a program manager or a business architect, you discover that there were major flaws in what was given out as being the program. So I spend more time focusing on front end rather than wasting time firefighting at the back end. So anyway, that's my view, and that's my personal view. And I think it's supported by a lot of what we've been saying today. So to find out more information, QFD Institute, these are some useful resources. There's a great website that Glenn Mazer has produced in the States, which has a load of case studies for the QFD aspects. And then we've got the INCOSE SEQM working group starting 1st of March 2023, just pushing that. And then you've got the QMI international website. That's where Larry Kennedy, that's his business, online training for management and leadership, specifically ensuring that management and leadership is done in a quality way, avoiding the kind of classic, the finance director has been discovered to be fiddling the books and has now screwed the company good and proper. So how do we train people so they know what they're doing? They're feeding down through the quality value chain. And this is my summary at the end of the day. How do we ensure we build quality assurance into system design, not try and fix it after we've put bad quality in? And the SEQM quality basically is providing a quality culture framework for QFD. It's a platform on which the QFD processes can work properly. So much of what I've seen in my career was me trying to push through an agenda of taking a KFD approach to system design, and then somebody saying, no, we haven't got time to do that. Let's go and do some firefighting, because that's what we love to do. So that's me coming from the heart there. And these are some paper references. Apologies if we've taken a few minutes longer than we planned.
Okay, that's it. Kim, thanks very much for that. And John, thanks very much for your contribution as well. We got 5 minutes or so for some questions. There are some questions coming in the chat now. If I can get my chat window open again. Excellent. I would like to say it's the first paper I've ever seen where somebody's referred to a bug that actually turned out to be a bug.
Yeah.
An actual insect. So, which I thought was excellent, because in my head I was thinking software bugs, and then you showed a picture of. So anyway, so thanks for that.
Yeah,
right,
it was for me. It was great illustration. We're told, no, we got quality assurance processes.
Yeah,
material supplier in Duxford, Cambridgeshire, and then hang on, what's this then? And of course, the problem for composites, that's my PhD, was in this area.
Right.
Was that you've got semi-cured resin, which now, because it's got gut of insect slopping around it, it's probably pre-cured before it gets into the autoclave. Right. And that's a major defect. That causes delamination and a whole load of other garbage.
Right.
And basically is not acceptable, so you have to throw the product away.
Brilliant. Okay, well, let's go to some of the questions from the attendees. So we got one from Sanji. First of all, he's thanking you for the excellent presentation, and his question is concerning vocational certainty. So he says vocational certainty resembles personal mastery, one of the 5 practices of organizational learning by Peter Senge. Is my assumption, this is his assumption, is that okay? Does that ring for you? Or
yeah,
it's competency.
Yeah. So maybe if I quickly say, the 8 attributes are really based on an analysis Larry Kennedy did of the teaching of Phil Crosby, who's one of the original quality masters. He's the guy who wrote Quality is Free, which we've got here. It's a great book. It basically talks about all the things KFD does, which is, let's get change early on to the system, which is what Edward Deming was talking about. Let's sort the system out before we get buried in firefighting. And this personal mastery piece that Senge picked up on, and we've got Glenn Mazer, who can speak to this much better than I can, and anybody else on the planet can talk to it. So what Senge was doing, I think, was almost summarizing stuff that Phil Crosby had produced, which was, and Glenn's taught quality management in the States.
Well, I can just see, Kim, that Glenn's got his hand up at the moment. So I'm just going to ask
Glenn, take over,
if he'd like to contribute to this, Glenn.
Yeah, my pleasure. Thank you, everyone. Peter Senge was a systems thinking person. And one of the best explanations I ever heard him give in lecture was, if you were to look at your finger, and it's comprised of bone and blood and tissue. Now you could put bone and blood and tissue in a dish, but it's not a finger.
Yeah.
So it's the vocational purity of it is not just the components being in place. It's the integration of them into a living system that brings about its uniqueness.
Okay.
Yeah.
Brilliant. Okay.
And I'm going to say that's very similar to another model that Russell Ackoff, is my big hero of systems thinking, who worked with Edward Deming, because it was all about the quality of the system that's critical, and the system integration is absolutely fundamental to this. And so often we get it wrong. We do the bits and we assume they're going to work together, and they don't.
Okay, brilliant. So
vocational certainty picks up on that.
Thanks for that, Glenn. I think he's also accidentally given away the secret recipe to KFC, but there we go.
Yeah, exactly.
We got another question here from Stuart H. Once you've identified your stakeholders, which elicitation techniques do you use?
So, and again, Glenn probably can talk to this best, but actually, the whole point of things like not only, but the Gemba visit, going and actually seeing what's happening, listening to what's being done, observing what's being done in the current environment, and understanding what problems the stakeholders face. And that's what I did at the beginning of the project back in 1990. Was I spent 6 glorious months visiting Luton, where the Lucas Aerospace, just up from the General Motors plant. So every time they did some car spraying, that the waft up the hill would almost help have people passing out around the production plant. I'm not sure what it was doing to the curing of the resins, because there was a new polymer appearing in our breathable environment. I was observing and listening and watching and finding out, where's the defects coming? Where are they introducing defects during production? You can't do it just from a requirements sheet. You've got to go and find out. Glenn tells a fantastic story about a power working tool and how they discover one of the critical design requirements had been missed by watching what was going on, which radically transformed the way a company developed its new products, by observing and seeing and listening and not going in with a preconceived idea of this is the solution.
Okay, Glenn, do you want to add something up for a few seconds?
Well, I have my favorite story as well. This is an example from one of the big automotive companies in the US. And they were suddenly experiencing a defect in brake disc pad delamination at very low mileage, like 3,000 miles or so. And normally they should last 25,000 miles. And they did all the investigation. There was no design change. The material suppliers were all certified. And they when they got to the Gemba, the work site where these batches of material were being made, they hunted around, could find nothing. They finally sat down with a couple of the line workers and said, has anything changed in the last 6 months? And one of the workers said, well, they did put a bathroom in here for us closer to our workstation. He said, well, okay, what did you do before you had the bath? Oh, we would pee in the vat of the mixture. And it was that additional urea that was providing strength to the composition that was suddenly missing. So until you see the site where things are happening, we sometimes use the term the crime scene, you really don't have all the evidence. And a lot of times it's hidden.
Fabulous story. Thanks for that. Right, we got time for one last very quick question. This is from Wendy. She says, how do you integrate QFD for upgrades of legacy systems where older QFD approaches may have been used in parts of the system? Or is it a case of starting from scratch?
So it's a combination of things. The core thing is to revisit and to assess every level. So it's almost, you've got to do it with intelligence, because people tend to hold on to the legacy. We did it. I've had this. I actually went in, I recommended within TRW Automotive that we go and do a QFD study on a power steering system. And they were very proud. They told me we did QFD in 1989, one of the early adopters out in the States. And so after a week, we'd established that there were a huge number of things that had changed and some of the work practices. So part of what we did was we went to the production site in Virginia, so the design office in Detroit. We went to the Virginia production plant and we started to uncover, this is what's going wrong with our current generation product, our legacy thinking. And this is QFD does that. Even with legacy systems, it opens up your eyes and your ears and your mind to things that have been accepted And the problem is that you then become like I did within IT, where you become the Victor Meldrew. Sorry, Glenn, this won't make any sense to you. Where I was regularly going into account for the enterprise system services we offered, and came away shouting, I don't believe it. I don't believe what we're doing here. We're not actually addressing customer needs because they're not listening to the customer. So legacy, it's sometimes you almost have to redesign your operation to really address the real needs, because the customer needs are changing. The priority on them is changing. As new technology comes on stream, that they'll suddenly think, oh, I can do that. Yeah, sorry, that's a rant from me, but it's a very good question, because people assume it's all about new product. It's not.
Okay, well,
it's about taking a continuous improvement mindset, even to the things that you think are already in the bag. Because markets will tell you very quickly, no, it's not in the bag. You've got to rethink your product, your service, your system, your whole operation. Or it might be just, we need to change one process.
Okay, I need a new broadband.
Yeah. Right, we're gonna have to call a stop to things now, which is unfortunate because we've got an excellent discussion going here. So first of all, on behalf of Incosi UK, thank you, Kim and John, and their transatlantic sidekick Glenn today, for contributing to everything that we've done. It's been a really excellent talk.
Just to explain,
I don't, Glenn is one of the authors.
We're the sidekick to Glenn.
Yeah, I just want to give you your 15 minutes of fame. That's all, Kim.
Thank you.
But thanks for it. It's been a really good session.
Yeah,
I hope everybody's enjoying it. And I say on behalf of Incosi UK and myself personally, it was really good to see you again. We're all looking forward to seeing the QFD Don't Panic guide at some point.
Yes. Thank you for mentioning that. We did wonder. So we're going to make sure Glenn writes the forward.
Perfect.
Which he says either, you done good sidekicks or you done bad.
Excellent. Well, on that note, thank you very much, everybody, for joining us, and keep in contact with Incosi UK, and we'll see you all soon.
Yeah, we'll do.
Okay. Thanks, guys.
Thanks very much. Bye-bye.